Alrighty, guys. Looks like nobody else is joining, so let's just get started with today. Quick mic check. Can everybody hear me loud and clear? Any background noise or anything?
You're good. I can hear you.
Awesome, perfect. All right, awesome. Wait, I don't know if Minhwa can hear me, because he hasn't replied. But I guess if they can't hear me, then I'll just say, okay, all right, awesome, perfect. All right, so yeah, welcome to week 2, day 1 of Jumpstart. So if you guys are coming from week 1, then you guys already have an idea of how Jumpstart goes, but just in case you guys aren't, I'll just go over it again. Because this week is going to be a little different. So week 1 is meant to prepare you guys for the coding challenge, whereas week 2 is meant to prepare you guys for the technical interview. So for this week, instead of letting you guys go at the end of every class to work on the problems, you guys will be pair programming with each other, because one of the portions of the technical interview is pair programming, and it is pretty important. So it's good that you guys get some familiarity with it, understand the roles and responsibilities in a pair programming scenario. I will give you guys more details about that at the end of class today. For today, there's not going to be any review because there wasn't any new material on Friday. So we're just going to be jumping right into lecture. And then after lecture, you guys just work on the problems on your own as you would like last week on your own. And I will send you guys a document detailing the roles of pair programming. All you guys have to do with that document is just read it, understand what goes on in pair programming, and come tomorrow with any questions, or just shoot me a message on Slack about any questions that you may have about pair programming. So tomorrow will be the first day of pair programming, and you guys will pair program until Thursday. But yeah, any questions for me before we get started? All right, got one. Nope.
Question, pair programming is kind of like talking through the problem together.
So pair programming is so if you think about it, right, when you solve a problem, there's a lot that goes into it. You have to read the prompt, you have to understand what each section is saying, and then you come up with an approach and you type that out. So when you pair program, you split the responsibilities with another person. So there's the navigator. I'll just give a high level overview of what pair programming is. So there's a navigator and there's the driver. The navigator tells the driver exactly what to write word for word, and the driver will write exactly what the navigator tells them. So what this helps to do is you have two eyes, or two sets of eyes looking at the same thing, right? Looking at the same screen. So any errors that will be overlooked by one set of eyes can be caught by another pair. So that's really what it helps to overcome. And you have two people working on the same problem, so you have more ideas coming in, more approaches and different insights. Somebody might be stronger in one aspect, somebody might be stronger in another. So you have like two minds on one problem.
Okay, sorry, another question then, for the interview process. Are you, then are we working on the problem together with another interviewee?
No, you guys are working with the interviewer.
Okay, I
so,
see.
Yeah. So
but they're not helping you. They're kind of just seeing like how you would kind of work out a problem.
So they're not helping in that. So like I said, there's the navigator and the driver, right? So the navigator will come up like with the approach. Well, you guys will collaborate and come up with the approach, but the navigator usually has more control in that part. Yes. They have more say. So you will be the navigator first. You will tell the driver, the interviewer, exactly what to write word for word. And once the interviewer sees your approach, then they're like, all right, this is the route we're going. I can continue on. So after like, I think a couple of minutes, you guys will switch, and they want to see how you perform as a driver. So they really want to see how you perform in both scenarios.
Okay. And then I'm sorry, one more question.
Yeah, no problem. Keep on asking.
On the job, in terms of like this kind of pair programming, does this happen in like when you're working to like when you're kind of working on a project together kind of thing?
So there are some companies that do pair programming. I know one of my friends, he works at a company, and do encourage pair programming. Even the interview is done in pair programming for that job, where you would interview with like a senior engineer, and they see how you collaborate and stuff. And even for jobs that don't require pair programming, it's still good because you still have to collaborate with your team, right? You still have to collaborate with your engineers, your peers, other teams. So it's good to have like, or build on your collaboration skills, your communication skills.
Okay.
So yeah, it doubles up on that too. So, yep.
Okay. Thank you.
Yeah, no problem. Any other questions, guys?
Nope.
All right, awesome. So let me just set up lecture really quickly. Like 30 seconds. All right, let me grab the screen share. All right, can you guys see where it says enumerables as a comment and then a whole bunch of like this?
Yep.
Sweet, awesome. All right, so the topic for today's lecture is going to be enumerables. So what enumerables are basically just built-in methods in Ruby that we use to make common patterns that we use while loops for more concise and clean. So one common pattern that we use a while loop for is iterating through an array or a string, right? And I'll show you guys an example of how we do something using a while loop, and then we'll convert that example into an enumerable, and we'll compare the examples. But before that, I'll give you guys a blueprint for any enumerable. Just give me 1 second. Let me just put this in here. So yeah. So first up is the blueprint for any enumerable. And I should also just say these enumerables, like all they're meant for is just like cleaning your code up. They don't really do much else in terms of like functionality, I guess you can say, because while loops allow you to iterate through an array or a string. Enumerables allow you to do the same exact thing. They just give you another way to do it. So all they let you do is do the iteration. The core of what you want to do for each element in an array would still just be the same in both scenarios. But yeah, we'll compare and come back to that point. So let's say we have a variable ARR, and which is holding an array that we want to iterate over. So using the .each enumerable, which is going to be the first enumerable we'll be talking over, you would do something like this. You would do ARR.each do, and then 2 pipes. So these 2 pipes you get by pushing the shift and the backslash on your keyboard. And what goes inside these 2 pipes or between these 2 pipes is called a block parameter. So you can basically think of this block parameter as like a variable that you define that is being recycled at the end of every iteration. And we'll talk more about how the block parameter works once I jump into an example. It'll be a lot less confusing than if I try to explain it now. But inside the .each, you put some code to execute whatever you want to do for each element in the array. And then you put your end keyword, letting Ruby know that this is the end of the .each. Any code after the end is not part of the .each. So there are enumerables for different data types. We'll start off with enumerables for arrays first. So let's say we have an array called months, and it is storing the elements January, February, March, April, May, and June. And we just want to iterate over this array and print out each element. So using a while loop, we would do something pretty similar to this, right? We would do I is equal to 0, while I is less than months dot length. We do month is equal to months at the index I. This step isn't really necessary. You could just do puts months at the index I, but I just want to put this in here because it'll make it a little easier to understand enumerables, block parameters. So If we want to print this out, we would just do puts month. And then we would do I plus equals 1 to make sure we don't fall into an infinite loop. And then we put our end keyword. So if I pop open a terminal, let's move this to the right, expand it out. Give that a run, and nice. You'll see that we get all the elements from the array printed out one by one. And that's awesome because that's exactly what we were doing, right? We start off on the beginning of the array, we continue on until the end of the array, we grab each element, we print it out, we move on to the next element. So using the .each enumerable, this would look something like this. So let's put .each as a comment. So any enumerable can be written in two forms. There's the multi-liner where you have multiple lines of code inside of your .each, inside of any enumerable, I should say. And there's the one-liner where you only have one line of code, and that is your enumerable. So I'll show you as the multi-liner version first, and then we'll talk about how we can convert that into a one-liner, and then we'll go ahead and do that. So multi-liner, up first, we do months.each do pipes month. So over here in pipes, we put a block parameter, like I said. And for this example, month is the equivalent of months at the index I. So this line right here, right? All it was doing was going into the months array and grabbing the element at the ith index, right? So if month was, if I was 0, it would just go inside the months array and grab the element at the 0th index. If I is equal to 1, all it did was go into the months array and grab the element at the first index. This block parameter, all it does is it's doing the same thing for us. So we don't notice how it didn't define an I variable over here, right? So now I have no way to actually index into my array. And that's because this is what the .h aims to clean up, right? We don't have to do all that variable definition and all that we usually do. So now if we want to just print out the month, we would just do puts month. And then we put our end keyword. So if I give this a run, you'll see that we get the same exact output as before using the .each, using the while loop. And now this is definitely a lot less code, right? This is only 3 lines of code, right? This is just a comment, so it doesn't count as code. There's only 3 lines of code compared to like 6, and it's doing the same exact thing. And like I said, the month block parameter is being recycled as a variable at the end of every iteration. So let's walk through an example, or let's just walk through this example and see what's happening at each step in this .each. So Ruby is, when we run this code, Ruby goes down the line, it defines this months array, then it gets to line 27, and it's like, oh, I need to do some iteration. I need to iterate over the months array, and the .each tells it that it's going to iterate over each element. And then we put the do keyword, and this is telling Ruby that we are going to refer to each element as month. So Ruby's like, all right, let me just see what I have to do. So it's like puts month. So at the beginning of the iteration, Ruby starts off at the beginning of the array. It'll grab January. So month is equal to January. Then we print out month. So we print out January, as we can see right there. And then that's all we do. So Ruby reaches the end keyword, but Ruby is not done with the iteration yet, right? Because there's still more elements in our array. So Ruby comes back up here. It's like, all right, month is now equal to February. And then it prints out the month. So then it prints out February. It reaches the end. It's like, all right, there's some more stuff for me to iterate over. Let me set month to March. And then it prints out March. And then it starts back from the top, sets month equal to April, prints out the month, reaches the end, starts back from the top, sets month to May, prints out May, and then it's like, all right, that's the end. There's still more elements for me to iterate over. It'll come back to the top, set month equal to June, and then it'll print out June. And then that's when it reaches the end keyword. And it's like, all right, I'm also done iterating over the entire array. That's all I have to do. So Ruby just, then it moves past line 30. But there's nothing else after line 30. So that's the end of our code. Any questions about that process? All right, got one no. I don't. All right, awesome, perfect. So yeah, let's move on to our next topic or our next point then. So like I said, any enumerable can be written as a multi-liner and a one-liner. So over here, I showed you guys a multi-line version. So to convert any multi-liner to a one-liner, it needs to satisfy just one condition. And that is that between the dot each do line and the end line, there must only be one line of code. And over here, we do satisfy that condition, right? Between the dot each do and the end line, there is only one line of code, right? Just only 929. This is just a comment. This doesn't count as code. So there's only one line of code. So in order for us to write it as a one-liner, all we have to do is turn this do into an open curly brace, turn this end into a closed curly brace, and just put everything on one line. So that looks like this. So a comment here that says one-liner. And all we do is months dot each, open curly brace, pipes month, puts month, close curly brace. And if I give this a run, you'll see that we get the same exact output as the 2 times before. And now this is only one line of code compared to 3 and compared to 6. So definitely a lot more concise. And if you know Ruby or programming, this almost reads like pure English, right? Like, all right, months, you're iterating over each element. You're gonna reference each thing as month, you're printing out the month. Whereas over here, you kind of have to do quite a bit of reading to understand what's exactly happening, right? And that's mainly because like this while loop, there's so many factors in it that completely alter the behavior of the iteration. Whereas the dot each, it's implied behavior. It will be like, are you using the dot each? You must want to iterate over every single element. So that's exactly what I'm going to do. Whereas for the while loop, right, we can change the I variable and that'll change where the while loop starts, right? So if I just comment that out and I comment this in, right? If I change I is equal to 1 and I give this a run, we'll completely skip January now, right? Because now we're no longer starting at 1. If I change it to 2, we'll just completely skip January and February. This while I is less than months dot length is ensuring that we go until the end of the array. But if I change this to a -1, give that a run, now we just completely skip, or we don't even reach June. I could change that to -2, and now we don't even reach May. All we're printing out is March and April. And another thing we can do to change the behavior is change this I plus equals 1, right? This I plus equals 1 is ensuring that once I'm done with a single element, I move over one element. If I change it to 2, now I will move on to every other element, right? So I'll start off with January, completely skip February, then March, skip April, May, and then skip June. Can change it to 3 and print out every third element, right? So we'll just print out January and April. So there's a lot you have to read in for a while loop to understand how it's going to behave, not even what it's going to do for each element, right? This is just the behavior of the iteration. Whereas the dot each, you don't have to worry about all that. Ruby is like, you're using me. There's only one reason you would use me, and it's because you want to iterate over every element. So that's exactly what I'm gonna do. But yeah, any questions about that one-liner or anything I just said?
How do you skip over? Because instead of doing iteration for every single one of them, how do you just do the same for, like with the while loop, you get to kind of define the counter, but then for this like dot each, you don't. So how do you kind of skip over some?
So the thing is, it's really weird because the dot each is going to hit every single element. There is no such thing as skipping elements in a dot each. The only thing you can do is not do something for certain elements, in which case you kind of skip them, but Ruby will still iterate over them. Whereas for this, like a while loop, Ruby is indexing straight into that, right? So it's not even like if I change this to I plus equals 2, right? and I do January, it's not even going to touch February, right? It's just going to go right over it because months at the index I is going to be 0 and then 2. So it's not even going to touch February. It's just going to go right over it. Whereas the dot each, it will hit every single element. But I will show you as another enumerable where we have access to the index. Where you can say, hey, if the index is not even, don't print this. But Ruby still has to reach that element and be like, all right, is this element's index even? If it is, then print it out. If it's not, don't print it out. So it still needs to touch every single element. So that's why it's called the dot each, because it's going to touch each element.
Gotcha.
Yep.
So if we were to want to skip over an element, we would have to go back to using the while loop.
Not really, just because it doesn't really make a difference, but it was just like a small technicality why I didn't want to say, yeah, the dot each just skips over every single element. I will show you guys how to get that same behavior, because you can still do that with the, not with the dot each, but with the next enumerable I'm going to show you guys.
Okay, thank you.
Yeah, no problem. Any other questions? All right. So yeah, like I said, so this dot each, it doesn't give us access to the index, right? We only have access to the actual elements themselves in the array. So sometimes we do want access to the index, right? And we don't want to have to revert back to the while loop or introduce like a I variable with the dot each, because that kind of defeats the purpose of dot each, right? So there is another enumerable that is available to us that gives us access to the index, and it is just called the dot each with index of dot each underscore with underscore index. So multi-liner version up first. So this is used the exact same way as a dot each, whereas like how it's written. The only thing is we now take in an additional block parameter. So we do months dot each underscore with underscore index do, and then pipes month comma idx. So now there's two block parameters, right? So the first block parameter will always reference the actual elements themselves in the array. The second block parameter will always reference the current elements index. So Ruby isn't like, oh, hey, you call the first block parameter month, that must mean you want to access the elements. And since the second block parameter is called idx, that must mean you want the index. So that's just not how it works, right? It's positional. So the first block parameter, no matter what I call it, I can call this potato. It's going to reference every single element in the array. I can call idx, I don't know, water, and it'll reference the current elements index. So oh yes, I just randomly said that. But the point was we could call them whatever we want. We just want to give them meaningful names. But yeah, so like let's say over here month is equal to, so we just started iterating over this array. So month is going to be equal to January. IDX will be equal to 0 since January has an index of 0. The next iteration, month will be equal to February. IDX will be equal to 1 since February has an index of 1. The next iteration, month will be equal to March. IDX will be equal to 2 since March has an index of 2, and so on and so forth for every element in the array. So let's just say we wanted to print out each element with the index. So we would do puts month plus the string colon plus idx.to underscore s, and then we put our end keyword. So if we give this a run, you'll see that we get January 0, February 1, March 2, April 3, May 4, June 5. So every element printed along with their index in the array. And I don't know if you guys have covered this .to underscore s method, but all it does is it takes a number and it turns it into a string, because in Ruby, you cannot add a number to a string. You're going to get a type error. So I'll just show you guys. If you give that a run, you'll see no implicit conversion of integer to string, type error. So they're incompatible types, right? Because if you look at what's happening on this line in terms of pure data types, this month block parameter is coming from, sorry, this month is coming from this block parameter, which is coming from every element inside the months array. If we look inside the months array, every single element is a string. So it's safe to assume that this will always be a type string. And then we're adding a string to it. So this is a string plus a string, perfectly valid operation. That's just string concatenation. But then we have index. An index will always be an integer. It's always going to be a number. So now we have a string plus number. So the number throws Ruby off. Ruby's like, okay, I can't turn this number into a string, so I can add 3 strings together. So these are incompatible. Please fix it and come back. So what we do is call the .to_s method on it. All this does is tells Ruby, take this index and turn it into a string. So now we have a string plus a string plus a string. That's just adding 3 strings together, just string concatenation, perfectly valid operation in Ruby. So now if we give it a run, you see that we do not get that error. Any questions about that? Yep. So you'll see that if I change this to potato and I change the IDX to tomato, and now wherever I was using the month, I change it to potato, and my second block parameter is tomato, so I'll call that tomato. And if I give that a run, you'll see that it still works, right? Because these are, you can basically just think of these as like variables, right? All it's doing is telling Ruby, hey, I want to reference each element in the array as a potato, and each element's index I want to reference as a tomato. So you can call them whatever you want, right? But you kind of want to give them meaningful names, because this kind of wouldn't make sense to anybody, right? Let's change that back. No problem. Any other questions? Yeah, you can call it on other data types. So I'm pretty sure if I call it on a string, Ruby has no problem turning a string into a string. So you'll see that it still works. Let me put this mess up. You'll see that it still works, right? I call the .to_s on a string. So you can call them on any data type. Does that answer your question? All right, awesome, perfect. All right, so yeah, so if you take a look at this, right, this does satisfy the condition to be turned into a one-liner, right? Between the .each with index do and the end lines, there is exactly 1 line of code. So we can write this as a one-liner, and that's exactly what we will do. So let's have a comment here. This says one-liner, and then we'll just do months.each underscore with underscore index, open curly brace, pipes month, comma, IDX, puts month plus the string colon plus IDX .to_s, close curly brace. So we give that a run, and you'll see we get the same exact output as before. Nice. Any question about how I turn this into a one-liner or anything for any of these array enumerables? Oh, before I do that, I did say I was going to show you guys how to skip over every element, right? So let's just copy this and put this down here. So if you want to print every other element, right? So if we just clear this up and we give that a run, you'll see that we're getting every single element, right? So if you want to skip every other element, all I have to tell Ruby now is, hey, only print out the elements that have an even index, right? Because the pattern is even, odd, even, odd, even, odd. So it's every other element, right? So all I have to do is just tell Ruby, hey, if IDX mod 2 is equal to 0, then do this. And then we just put our end keyword. So now if I give that a run, you'll see that we get January, March, and May. And it's all the even indices that got printed out, right? So every other element, January, March, and May. problem. But yeah, so like I said, it's a small technicality, right? But like the dot each with index, it's still hitting every single element. It's just not printing any element that doesn't have an even index. So it's still going to go January, February, March, April, May, and June. It's not just going to go January, March, May, and that's it. But yeah, any questions about this? Yep, next up is enumerables for strings. So we'll talk about that too. So you'll see it's like 99% similar to this. So you can definitely do this with a string too. And so I said processing that info. If you have any questions after the processing is completed, just let me know. Okay, you said I get it now. All right, awesome, perfect. Alrighty. So yeah, since there's no other questions, let's move on to enumerables for strings. So let's get a couple of spaces in here. So let's put 4 strings. So let's say we have a variable word and it is storing a string of Jumpstart. And all we want to do is just iterate over the string and print out each element, right? So using a while loop, that will look pretty similar to this. I is equal to 0, while I is less than word dot length. We do char is equal to word at the index I, so a single character. We're just going into the string and grabbing this single character, so we just call our variable char, and then we do puts char, and then I plus equals 1. And we put our end keyword. And if I clear this up, give that a run, you'll see that we get every element printed out one by one. Every character from the string printed out one by one. So the enumerable for iterating over strings is the dot each underscore char. So it's pretty similar to the dot each. The only thing is you tag on underscore char. So the multi-liner version up first. We do word dot each underscore char, do pipes char, and then puts char. And then we put our end keyword. And let me just get some spaces in there. We give that a run. You'll see that we get the same exact output as before. But now there's only 3 lines of code as compared to like 6. So we cut the amount of code in half, or the amount of lines. There's definitely some more code over here. But yeah, so we can also write this as a one-liner, since between the dot each underscore char do and the end line, there is only just 1 line of code. So we can convert it into a one-liner, and that's exactly what we'll do. So we'll have a comment here that says one-liner, and then word dot each underscore char, open curly brace, pipes char, puts char, close curly brace. So we give that a run, and you'll see that we get the same exact output as before, the same exact behavior, right? All it's doing is iterating over the string and printing out each character. And now this is only just 1 line of code as compared to like 3 and like 6 or 7. I don't remember what that is. So yeah, pretty similar to the dot each. And just like before, like with the dot each, we do not have access to the index, right? We only have access to the actual elements themselves within the string. So if we want access to the index, we must, so there's not a separate enumerable for us to use. We chain on another method. I don't know why they designed it like this. It just is like this, so we have to deal with it. But it's written like this. So it's dot each underscore char dot with underscore index. So it's not the each underscore char underscore with underscore index, because that would let you know that there's only one, that's just one method. The dot over here lets you know that you are calling another method. So you're calling the dot with index on the dot each char. Yeah, it's written the same way though, or like the blueprint for it. So like the multi-liner version, is written the same way as like any other enumerable. So we'll do word dot each underscore char dot with underscore index, do pipes char comma idx. So this first block parameter is always going to be a reference to the actual characters themselves. the second block parameter will always be referenced to the current character's index. So if we want to print out each character with its index, we do puts char plus string colon plus idx dot to underscore s, and then we put our end keyword. So if I clear this up and we give that a run, you'll see that we get all the characters printed out along with their index. And this is a one-liner, right? There's only one line of code between the dot each underscore char dot with underscore index do and the end line. So we can go ahead and convert this into a one-liner. So we'll have a comment here that says one-liner, and then the word dot each underscore char dot with underscore index, open curly brace, pipes char comma idx, and then puts char plus the string colon plus idx dot to underscore s, close curly brace. So if we give that a run, you'll see that we get the same exact output as before, just one line of code now, as compared to 3. So a little bit cleaner. Nice, and that is really it for string enumerables. Like I said, it's like 99% similar to array enumerables. They behave the same way, the dot each and the dot each char, and the dot each with index and the dot each char dot with underscore index. I just really want to stress that this is the dot each underscore char dot with underscore index, because I don't know, it took me forever to like really remember that it's the dot with underscore index. So I would just run into some crazy errors because I kept on doing each underscore char underscore with underscore index. But yeah, that was really annoying when I first started learning Ruby. But yeah, any questions about this? Any, oh yeah, so all these pipes are telling Ruby between this, I'm about to put my block parameters, and that's all it is. The pipes have no other meaning besides that. All it's telling Ruby is whatever is between these two pipes is going to be block parameters. Awesome. Does that like fully answer your question, or was there like something else that was confusing you? Oh, okay. So I'll just go back to the beginning of lecture. I had a good example over here. Right. Okay. So over here, so we have this while loop, right? So I set up my while loop. I do I is equal to 0, and then I do while I is less than month.length, and then I do month is equal to months at the index I, right? What this is letting me do is grab an element from the array and store it in the month variable. And then I can just do puts month, and it'll print out that variable. Let me change that back to 1. And then it'll move on to the next element, right? So then it'll change I is equal to 1. And then it'll do months at the index 1. And then it'll grab February, store it in a month, print out month, move on to the next element. It'll change I to be 2. So then it'll do months at the index 2, and it'll grab March, store that into the month variable, print it out, move on to the next element. And it'll do that for every single element, right? So now using an enumerable, we do not have access to the index, right? We don't define it before the index. Notice how this I is defined before the while loop, right? And that's because I need to use it on the very next line. So I need to define it before I use it, right? I can define it on the same line in the while loop. So the dots each doesn't give you an index, right? So you don't have any way to index into an element. So you need a way to reference each element, right? Because if you just iterate over every element and you can't access each element, that's kind of useless, right? So we need a way to reference a single element that we're currently at in the iteration. This is where these block parameters come in. So this dot each, all it does is give us an alternative in setting up our iteration, right? So over here, to set up the iteration, I used I is equal to 0, while I is less than months.length, I plus equals 1, and then the end keyword, right? I needed all of this in order for me to just iterate over the array, right? This was just my core logic where I grabbed the element, printed it out. Over here with the dot each, this giving us an alternative. Yeah, you can. Yeah, it's basically just that. It's a parameter. It's basically just a variable that's holding the current element in the iteration. So, all right, awesome, perfect. All right, I popped out that array. But yeah, any other questions about this stuff? All right, I see silence in the chat. You know, so there are no questions. So let's move on to our.
Sorry. So for the one-liner, is it practical to use it? Is it better to use the multi-liner or the one-liner? Because I would imagine if it's something complicated, it would make the line super long.
Yeah, so that's definitely a great point. You do not want to sacrifice the readability of your code in order to just write lesser code, right? Because at the end of the day, it's the same to a computer, right? Whether I write a multi-liner, whether I write a one-liner, Ruby is still going to do the same exact thing. It's going to iterate over the array, print out each element, right? No matter if I use a while loop, an enumerable, a multi-liner, one-liner, what have you, right? So all these enumerables aim to do is make it easier for another programmer to read your code, or even you yourself to read your code, right? Because if you write some code now and you go back to it like 2 or 3 months later, you're gonna forget like what you did, right? Because it's been so long and you've done a lot more programming since then. You're gonna be like, what was I doing over here? So if you have concise code, it's easier to read, but you don't want to get too concise and sacrifice the readability of your code, because then it just gets difficult to read. So you do want to only use a one-liner when you can see, all right, this is a pretty simple line. If I turn this into a one-liner, it's not going to sacrifice any readability. It's just going to put everything on one line. If you have a multi-liner and you're like, hey, let me condense this as much as I can to try to fit it into one line, and it just becomes this crazy, messy like line that has like 100 characters in it, just don't do that, right? It's better to just have that on multiple lines. It's easier to read. That's all the same to the computer. Awesome, perfect. All right. Any other questions? All right, awesome. Wow, got a whole bunch of notes right all at once. All right, so let's move on to our next data type, which is going to be numbers. So I guess the only enumerable that we'll go over is the dot times, because it might be the only useful one at this point in your guys' software engineer careers. So all it does is it does something a number of times. So you tell it how many times you want to do something and what you want to do, and it'll just go ahead and do that thing that many times. So let's just say we wanted to print out like hello. Actually, before that, let me show you guys the dot times with a block parameter and without a block parameter, because it's pretty interesting that you don't really need a block parameter for like the dot times. So multi-liner version of first, right? So we see we'll do 5 dot times do pipes num. So we'll give it a block parameter, right? And then we'll do puts num, and then we'll put our end keyword. So notice how before, right? Whenever I gave it a block parameter, it like let's just use this .h chart, right? So I gave it a block parameter and it was referencing a character in the string, right? I was iterating over a string and it was referencing a single character from the string. Down here, I'm just doing something some number of times, but I'm not iterating over anything. So what can this block parameter give me? Well, let's give this a run and find out. So you see that we get 0, 1, 2, 3, 4. And that's because the dot times, in order for it to know how many times it's done something and when to stop, it needs to keep track of how many times it's done something, right? So notice how that although we only went up to 4, there are 5 numbers printed out, right? Because 0 counts as a number, and then there's 4 numbers, so there's 5 in total. So the dot times uses an internal counter. The dot times method, how it's implemented, it uses a counter to keep track of how many times it's done something. If you tell Ruby, hey, I'm giving you a block parameter, it gives you access to that timer, or sorry, to that counter. So you'll see that it starts off at 0 because when it first starts something, it's done something 0 times. So it'll be like, all right, puts 0. And then it'll move on to the next iteration. So it's like, all right, I did something 1 time already. Now I'm at 1. So it'll move on to 1, and then 2, and then 3, and then 4. Once it reaches 4, it's like, I've done something 5 times. That's it. It's time for me to stop. Yeah, any questions about that? All right, awesome. Got 2 no's. I don't see nothing coming into the chat. Gonna assume there are no questions. So let's write this as a one-liner just because we can write this as a one-liner. There's only one line between the dot times do and the end line. So we'll go ahead and write this as a one-liner. We'll have a commentary. This says one-liner, and then we'll do 5 dot times open curly brace, pipes num, puts num, close curly brace. So actually, let me just get some spaces in here, give that a run, and you'll see that we get the same exact output. Now it's just on one line, so it's cleaner code. So when we write the dot times with no block parameter, that's how come here it says no block parameter, multi-liner version up first. So let's just say we wanted to print out hello 5 times, right? We do 5 dot times do, and then on the next line just puts hello. And then we put our end keyword. So if I clear this up and give that a run, you'll see that we get 5 hellos being printed out. Nice. And to write this as a one-liner, all we have to do is do 5 dot times, open curly brace, puts hello, close curly brace. And if we give that a run, you'll see we get the same exact output as before. And now this is really just very clean and concise code, right? This almost reads like pure English. I guess the only non-English keyword is puts. But if you know Ruby, you know what puts does. But yeah, so just wanted to show you guys that if you don't put a block parameter, this is how you write a one-liner. And like all that matters is that there's only just one line of code between the dot times do and the end line. And you can write as one-liner. But yeah, any questions about that? Dot times? I know I'm asking you guys like every 2 minutes, I'm sorry. Thank you guys for being active in the chat though. Thank you, I appreciate it. But all right, it looks like there's no questions. So let's move on to our next kind of data type, it's ranges. So to denote a range in Ruby, we use parentheses, right? Like let's say I wanted a range from like 1 to 10, like all the numbers from 1 to 10, I just wanted to iterate over them or something, right? To denote a range, we use parentheses and then a start number. So over here, we'll start off at 1. And then you can put 2 dots or you could put 3 dots. We'll talk more about the differences in just a second, but let's just put 2 dots, right? And then you put an end number. So you put 10. The end number must always be greater than the start number. In Ruby. Ruby is not going to do reverse ranges. And I'll show you guys real quick. But actually, before I even move on, let's just print this out, right? So if I clear this up and I give this a run, you'll see that all we get is 1.10, right? Which isn't really helpful because I can't visually prove to you guys that this range contains all of the numbers from 1 to 10. So what I will be doing, just for visual purposes, you do not need to do this to iterate over a range, is I will convert these ranges into an array. So to do that, I'll just use the .to_a method, pretty similar to the .to_s. It's just that the .to_a converts stuff to an array. So we'll do p1.10 .to_a. Oh, whoops, sorry guys. Put that in there. p1.10.to_a. This is an inclusive range, which means it goes from 1 and includes 10. So if I give this a run, you'll see that this array creates every single number from 1 to 10. If I put 3 dots, that is an exclusive range. So if we do p1 dot 10 dot 2 underscore a is exclusive, which means it goes from 1 and excludes 10. So if I give this a run, you'll see that this second array does not contain the number 10. Although we did put 10 over here, this third dot makes sure that we exclude that from our range. And like I said, the start number must always be greater than the end number. We cannot have this, so we can't do p10 dot 1 dot 2 underscore a. You can't go backwards in a range. So Ruby is just going to return an empty range, turn that into an array, is just an empty array. But as you can see, this is a pretty easy way to get all the numbers from a range into an array. Right? So let's just say you wanted all the numbers within a range as an array reversed. You could do something like this. P1 dot 10 dot 2 underscore a dot reverse. And this will be inclusive, which means it goes from 10 down to 1. So if I give that a run, you'll see that we get this range, or sorry, this array of 10 down to 1. So this is not to be confused as like this is a range from 10 down to 1, because as you can see, we're chaining all these methods over here, right? So this, all Ruby does is it starts off over here. It's like, all right, I need to create this range from 1 to 10. Then it's like, I'm converting this to an array. So the dot 2 underscore a method returns an array. And then the dot reverse reverses that array. It does not reverse the range. But yeah, you can also create ranges for characters. So let's say you wanted like the entire alphabet, you could do p_a dot z dot 2 underscore a, and this will create an array of every single character in the alphabet from A to Z. And just like before, you can't go backwards even for character ranges. So if you try to do pz dot a dot 2 underscore a, you can't go backwards in a range. So if you give that a run, you'll just see an empty array at the end, because this returned an empty range. Turned into an array is just an empty array. Any questions about that?
Can you use dot reverse for other things?
I think the dot reverse is only available on arrays. Let's try it on a string real quick, because I think that's the only other thing you would want to dot reverse real quick. So we'll just do A, B, C, D. Well, not A, B, C, D, E, F. And then we'll just call the dot reverse on this. So we won't print it out. We'll just see if Ruby throws an error. It doesn't throw an error, so it might work. So if we print this out, let's clear this up and give that a run. Oh wow, look at that. It does reverse the string. So you can call the dot reverse on a string and an array.
Okay, thanks.
Yep, no problem. Any other questions? Oh, George, you said you had a question. Oh, okay. All right, so yeah, if there's no questions, let's move on to our next little thingy, which is going to be enumerables for these ranges. So if I want to iterate over an array, iterate over a range, I just use the dot each enumerable. So multi-liner version up first. Let's say we wanted to create a range from 1 to 5 and multiply each number by 2 and print that out. We would do 1 dot 5 dot each do pipes num, and then puts num times 2, and then we put our end keyword. So if I give that a run, you'll see that we get 2, 4, 6, 8, 10, which is just 1, 2, 3, 4, 5 multiplied by 2. And we can write this as a one-liner since there's only one line of code between the dot each do and the end lines. So we will go ahead and write this as a one-liner. We'll do parentheses 1 dot 5 dot each open curly brace pipes num puts num times 2 close curly brace. And if I get some spaces in here, you give that a run, you'll see that we get 2, 4, 6, 8, 10. Same as before, but now there's only one line of code. Nice. Any questions about this or like anything from today's lecture? this was really the last thing I had for lectures. So if you guys have any questions at all, feel free to ask. That's a tough one to answer just because, well, first of all, I did my technical interview 2 years ago. And any interview is kind of just luck, right? Because you're never going to be 100% strong at every single thing. So you kind of just hope that you only get questions in the aspects that you're strong in, or the topics that you're strong in, right? If you get something that's a little tougher for you, you might not get it, right? And like, it also just comes down to like, do you understand the question that they're asking, right? Sometimes you could just be like too nervous and you don't understand the question that they're asking. It could be very simple that something so simple that you could have gotten on your own if you weren't in like an interview setting with all the pressure on you. So there's really just like so many factors into it that it's really tough to answer about how hard the technical interview is. But like, we do keep in mind that you guys are beginners. You guys aren't like pros at this, so we're not going to ask you like some absurd question. It's going to be covered. It's not going to be outside of the scope of week 2 material. Wait, like tomorrow? Like Tuesday tomorrow? Wait, this is week 2. Oh, okay. So, to be honest, Wednesday should be fine. You should be perfectly fine. Wait, when is it on Wednesday? And you're in EST, right? Yeah. Like, what time is the interview on Wednesday? Because there is a topic that you should know. Or actually, usually we wait until Wednesday to do this. So I would recommend, since your interview is on Wednesday, I would recommend after you work on tonight's problem set, if you haven't already, please go straight to week 2, day 3. Wait, for the first one, so this is the coding challenge, right? Not the technical interview, or did you already pass the coding challenge? Okay, so this is the technical interview. Okay, so yeah, I would say go to week 2, day 3, and learn hashes, because that is a data structure, so it's going to be important to know. And if you have any questions at all as you're going through the material for hashes, please feel free to shoot me a message on Slack. I will help you right away. Hashes is pretty important to know, so I would say go straight for it. Week 2, day 3. Yeah, no problem. And like, please feel free to shoot me a message no matter what time it is. Please shoot me a message. I will help you out. Yep. But yeah, any other questions from anybody? I also just want to say, Gerard, so like, you should focus on that. Like, I would say try to do that today, but please like try not to miss tomorrow's class, just because tomorrow is the first day of pair programming, and part of the technical interview is pair programming. So you should have like at least just like 1 day's worth of like familiarity with how pair programming goes, because that is part of the tech interview. So I would say like try not to skip tomorrow's class. Awesome, perfect. Alrighty, guys. It's already 7:35. I will not hold you guys up any longer. I will stop the screen share since there's no other questions. I will send you guys these notes on Slack, so you guys will have access to them as you guys are working through tonight's problem set. Let me just send you guys these before I forget. My computer. And I will also send you guys that document that I was telling you guys about that details the roles of pair programming. Please read this document before tomorrow's class and come with any questions that you may have, or shoot me a message on Slack about any questions that you guys have. But yeah, it's 7:36. Give yourselves like a nice 5-minute break, and then please get started on the problem set for tonight. That is under week 2, day 1 on App Academy Open. If you guys have any questions at any point in time, please feel free to shoot me a message on Slack. I will be more than happy to help you guys out.
Thank you.
Yeah, no problem, guys. Yep, no problem. Have a wonderful night, guys, and I'll see you tomorrow.